In this video, we have the definite integral of sine of x over 1 plus cosine squared of x. The limits go from pi over 2 to pi. There's a way to simplify the integrand. You can go ahead and do it. I know the derivative of cosine is minus sine. I have the sine function in the numerator. So it looks like I can write this integrand, or the integral actually, in this format. Integral of du over u squared plus a squared. And this, of course, gives you the value as 1 over a arctangent of u over a. And of course, in our case, we have a definite integral. So we have to apply the limits of integration. And of course, this formula was derived using a trig substitution. We looked at several problems. If you don't use this formula, you can do a trig substitution. But whenever possible, you want to use this formula if it applies. And in this case, it does apply, but we have to set it up. We'll set it up this way. We'll let u equal to cosine of x. We have the cosine here squared. So we let u equal cosine of x, then du would equal to the derivative of cosine, which is minus sine of x dx. So we have a replacement now for sine of x dx. Let's multiply both sides by a negative here. We'll make this a plus, and the negative will be over here. This will be a negative there. This will be a positive here. And I'm going to do this U-substitution. So I'm going to change the limits of integration. I can leave the same limits if I do the integration with the U-substitution, and then go back to the original variable. This way I don't have to do that. I'll simply say the lower limit is pi over 2. So if x is equal to pi over 2, that would imply that u will be 0. Plug it over here. X 0, cosine of 0 is equal to 0. And if it turns out that x is equal to pi, go back up here to the substitution, u equal cosine of x, cosine of pi would imply then that u is equal to a negative 1. So we can rewrite this. Instead of pi over 2 to pi, this is going to go from 0 to negative 1. This will be a minus du, replacing sine of x dx by minus du. And the denominator we have 1 plus, and the cosine of x is u, so this would be then u, and then it has a square. And I can actually work the problem this way, or since I have a negative here, I can bring this negative over here and change the limit, and it changes to a positive. That's one of the properties of the definite integral. So this then becomes from negative 1 to 0. And this is just du over 1 plus u squared. So canceling the negative changes the limits of integration from 0 to negative 1, from negative 1 to 0. Now the integrand has the form that I want. So this is going to just be arctan of u, and this would be your a squared in the formula. Means a will be 1. So this is u over 1, but that's just going to be u. And then the coefficient from the formula is 1 over a, but a is 1, so it's 1 over 1 stays arctan of u. And then this is evaluated from negative 1 to 0. And then we just plug in here. So this is then going to be arctangent of 0 minus the value at negative 1. So this would be arctangent negative 1. This is going to equal to the arctangent of 0 is 0. That's minus the arctangent of negative 1. And we're dealing with radians here, so the arctangent of negative 1 is negative pi over 4. So 0 minus a minus pi over 4, this will just give us positive pi over 4. And that's the value of this definite integral. Thanks for watching. We'll see you next time.